Okay, we're now looking at electrical heater, and we're told the power output of the heater is 2000 watts. So that means it gives off 2000 joules every second. And the heater is connected to a 230 volt main supply. What's the equation that links power, voltage and current? Well, voltage times current equals power. Okay. And again, it's just one of those things that you have to learn. And if you haven't learned, it tells me that you probably haven't done a good enough revision. So calculate the current in the heater. Well, if we rearrange this equation, I is going to be equal to power over voltage. Remember, I is current. So we're going to get 2000 watts. We're going to divide it by 230. And the answer is 8.7 amps. So we're going to give 1 mark for the working, 1 for the answer, none for the unit because they've already given it to you. Now they then have to ask you to choose which of the fuses should be used with the heater. Now we're not just going to go with the closest one. We have to go with one that is greater than the current that the heater is supposed to operate on. Because this is saying that 8.7 amps, this is the normal running current for the heater. So if you've got a 7 amp fuse in it, it would blow straight away and it would never really work. So we always choose the fuse that is slightly higher, the next one up, from the current that it knows. Now, the two heating elements could be connected in series or parallel, and you've got to give an advantage of each. Well, when we're looking at series, our main advantage really is that we can turn them both on and off together. So let's say you have heaters on either side of the room, you want to walk into a room and switch them on, you've only got to press one switch. Now the advantages of parallel, one of the advantages is that if one heater was to break or to malfunction, then the other one would remain on, and that means that obviously your room is still partially being heated even though one of them is broken. Now the next part on here is asking about the earth wire. 4 marks here, so quite a lot expected of you to describe how an earth wire acts as a safety feature. Okay. Now I'm going to kind of show you the mark scheme for this bit. And these are the things that they're looking for. So any of these 6 marks is worth a mark. So first of all, the earth wire is going to be connected to the metal casing. If the appliance has a plastic casing, then you don't need an earth wire. Okay, so it will be connected to the metal casing, and if there's a problem inside the device, say for example the live wire touches the metal casing, again that's worth another mark, then the earth wire then provides a path which charge can escape to earth. Now you need to be specific here that it's a low resistance path to earth, because if it was a high resistance path, then there'd be no extra reason for the electrons to take that path. So the fact it's a low resistance path will mean that pretty much all of the electrons are going to flow through this wire to the earth. Now that by itself is not enough though, because the electrons are just going to keep flowing through that path. And it might be that the metal casing is part of that path too, so that the electrons are passing through the metal casing, through the earth wire to ground, but there's a continuous stream of them, of current. Now, the key thing is that this causes a large current to flow. Because the resistance is so low, you're going to get a large current flowing. And that's going to cause the fuse to melt. And that fuse melting is what switches off the circuit. Without it, okay, electricity would flow through the earth wire, but it would just keep flowing through the earth wire. We need the fuse to break in order to switch off the circuit and stop the current from flowing. Now, why should the heater be fitted with an electrical wire? Well, the first thing is that in the diagram at the start it says that the heater has a metal case. Okay, that's the key bit about it, because insulating cases will not require an earth wire. We say that they have double insulation. Okay, you get the second mark if you say that metal is a good conductor, or you can say that this prevents the user getting a shock. Any of those kind of 3 points can be worth the mark.